Okay, just a fun slideshow about Fibonacci numbers and the golden ratio. In our assignment, we talked about how you generate Fibonacci numbers by adding two numbers to get the next number in the sequence. And as these numbers get larger and larger, the quotient of the last number divided by the second to the last number veers towards this golden ratio 1.618 or something like that. And you know, this 1.618, this golden ratio, is found very commonly throughout nature, and it's often called the divine proportion. And here's an example, like if you were to measure from the top of your shoulder to your elbow, you have a certain length here, okay, which we'll call that length C. And then if you were to measure from your elbow to your wrist, that's length B. If we were to divide length C by length B, that quotient would be about 1.618, or the golden ratio, okay? And then, you know, same here, if we were to divide segment B by segment A, which is the length of your hand, again, you would find that divine proportion, or the golden ratio, 1.618. And like, we can even break it down to your fingers and the bones in your fingers and measure those. And so you'd see that number all over the place. And I mean, not just in your arms, but like probably in your legs and, you know, your torso, and like all kinds of you know, measurements throughout the body, and then also other areas of nature too. And you know, one thing I want to mention, there's this thing called a golden spiral. Well, here we're looking at a golden rectangle. So let's say you were to take a piece of graph paper and start plotting or blocking out Fibonacci numbers. So we start with 1, 1 plus 1 is 2. So we have a square 2 by 2, right? The next number of the sequence would be 3. So we have a 3 by 3 square. And the next number in the sequence would be 2 plus 3 equals 5. So we have the 5 by 5. And then 3 plus 5 is 8. We have the 8 by 8, and so on. So we can just keep going and going with a huge piece of graph paper and plotting these, you know, golden rectangles. So if we were to draw a curve through each of those squares, we would get this, which is called a golden spiral. And this again is found throughout nature, especially in plants. See that very commonly. Here's a perfect golden spiral juxtaposed with a rose. And so you can see the way a lot of plants spiral around, and they're following these proportions. Okay, now I'm just kind of having fun. I don't know if these are true golden spirals. Some of them are, and I will let you know. I don't think a nautilus shell is a true golden spiral, but it certainly looks like one. And, you know, I don't know about the seahorse tail, but I don't know about this. But this is a golden spiral. The bands of the Milky Way follow that pattern. And I do believe fingerprints are also true golden spirals. Well, we'd have to look that up, but I think I did, and I saw that it was in fact a golden spiral. And well, you can decide whether or not this is a golden spiral. Okay. All right, and then very quickly, you see a lot of these proportions in art, and especially like those Renaissance masters, Da Vinci, Michelangelo. They had a very keen sense of this divine proportion, and they used it to compose their works of art. So yeah, there you go. Oh, and then this is a Fibonacci mask, and again, you know, you have the golden ratio all over the place in all these measurements. But, you know, I typically, like, supposedly, these are the ideal proportions for a human face. And if you transpose this onto somebody's face, the closer the match with the features, supposedly the more attractive or proportionate you could say that face is. So here's Queen Nefertiti, And you can see it's really a perfect fit with the golden ratio or the Fibonacci mask. Okay, and that's it.